Beyond our galaxy lie countless stars, but this one stands apart. The first close-up image of a star outside our galaxy reveals a red giant that is a staggering 2,000 times larger than our Sun. This colossal discovery is transforming our understanding of the universe. Located approximately 160,000 light-years away, astronomers have identified this massive red giant and fittingly named it Behemoth. Red giants are aging, bloated stars nearing the end of their life cycle, a common occurrence in the cosmos. Yet, WOH G64 is truly exceptional. This groundbreaking close-up not only showcases a remarkable star but also one of the most extraordinary red giants ever observed. Behemoth resides in the Large Magellanic Cloud, a neighboring galaxy that has been orbiting the Milky Way for billions of years. This galaxy, home to around 30 billion stars, has an irregular shape, likely influenced by past interactions with the Milky Way or the Small Magellanic Cloud, which have altered its original structure. Scientists even suspect that the Magellanic Cloud could merge with the Milky Way in a few billion years. This merger would change the structure of the Milky Way once again. New star-forming regions would emerge, and the upcoming merger with the Andromeda Galaxy could create a fascinating dance of three merging galaxies. WOH G64 will probably no longer exist by then. The giant star will explode in a few thousand to 100,000 years. Sensational image thanks to the Behemoth star. Technology, the Behemoth. What makes a giant star a monster? Is it its sheer size, the boiling hot inferno raging on its surface, or the difficulty scientists have in studying it? Scientists call red giants behemoths, a reference to the Book of Job in the Bible, where behemoths are described as gigantic, fearsome creatures. Behemoths are not only strong and large but also bearers of extraordinary divine creation. On the one hand, the sheer size of this star is fascinating, and on the other hand, so is the violence with which this star will burn up in the not-too-distant future. During the time when the star has blown itself up to become a red giant, it will burn everything around it. If WOH G64 once had planets in its vicinity, they will have been swallowed up by the star in a long process of growth. So, truly epic and biblical dramas are taking place here. It's estimated that in about 4.5 billion years, our Sun will also start to swell and gradually absorb all the planets. Fortunately, this point in time is reassuringly far in the future. It's much nicer to observe such a spectacle from a safe distance than to experience it on our own cosmic doorstep. WOH G64 has been known to researchers for quite some time, but until now, it was not possible to get a close-up of the star and thus learn more about the processes on its surface. This has now been achieved thanks to the development of a completely new technique. Gravity is a new instrument at the European Southern Observatory's Very Large Telescope Interferometer in Chile. The VLTI is one of the most advanced astronomical instruments in the world. It combines the power of up to 4 8.2-meter telescopes with up to 4 additional smaller auxiliary telescopes. With these so-called unit telescopes and the extensions, the VLTI creates a single virtual telescope that provides unparalleled resolution. If we were to put together all the individual parts of the telescope, we would have a telescope with a diameter of up to 200 meters. With this technique, researchers are once again achieving unprecedented precision. With gravity, researchers have now increased the telescope's capabilities even further. This groundbreaking instrument uses interferometry to combine the light from all the telescopes. With gravity, astronomers can observe stars and planets with an accuracy of a few millionths of a second of arc. This precision is roughly equivalent to being able to see the wings of a butterfly on the Moon from Earth. Gravity has now provided the first close-up of WOH G64, and the data is stunning. Close-up reveals surprising insights. What do researchers do with a close-up of a giant star 160,000 light-years away? Quite simply, they meticulously analyze every tiny speck of light to find out everything there is to know about that star. The human urge to explore is truly unique, and so we use every technology available to us to unlock all the secrets of the universe. Think of it this way: scientists can break down each pixel of such an image into dozens or even hundreds of pieces. Special spectrometers and computer programs analyze the recognizable light traces and, like detectives, can read incredible details from this information. In this way, our science can easily find out exact details about a star that is incredibly far away. Long-term observations of WOH G64 have shown that the star's light has dimmed over the past 10 years. Now, finally, researchers can find out details about why this is so and what connections there are to the star's life. Gravity technology allows researchers to observe the star in real time and to document processes in detail. Researchers warn that WOH G64 is so far advanced that any major change could be a harbinger of its explosive end. Unlike, for example, Betelgeuse in our own galactic neighborhood, this red giant has already begun to shed its outer parts. The star is already falling apart, and the egg-shaped ring that you can see in the photo consists of this ejected material. The shape of the cocoon fascinates scientists so far. No computer model and no simulation has been able to explain how this unusual shape came about. So there are physical forces at work around WOH G64 that we don't yet fully understand. Since the star's light is already weakening, researchers fear that further close-ups will soon be impossible. The researchers are planning to upgrade the technology in the Atacama Desert specifically for this purpose. Imagine that observing a star like this one is of such great value to science that no effort or expense is spared to examine this star in detail until the very end. Is it possible that WOH G64 will offer a unique opportunity to watch a supernova live in the near future? The Large Magellanic Cloud, a cosmic jewel. Let's take a closer look at the location of the spectacle. WOH G64 is part of the Large Magellanic Cloud. This impressive neighboring galaxy of the Milky Way is located in the constellation Dorado, or Swordfish. If you look up at the night sky, you can see the Large Magellanic Cloud with the naked eye. It appears as a small misty spot in the southern night sky. It was named after the Portuguese explorer Ferdinand Magellan, who documented the cosmic nebula during his circumnavigation of the world in 1519. At that time, the sailors had no idea that they would see thousands of other suns and even entire galaxies in the night sky. For them, the stars were points of light in the sky and signposts for their journeys across the oceans. The Large Magellanic Cloud is in our immediate vicinity at a distance of about 160,000 light-years. It's considered a satellite galaxy of the Milky Way. The Magellanic dwarf galaxies are probably gravitationally bound to the Milky Way. Structures can be seen in the interior of the Large Magellanic Cloud that suggest the galaxy is on its way to becoming an elliptical bar spiral galaxy. At the moment, however, its shape is still very irregular and not nearly as beautiful as that of our Milky Way. The Large Magellanic Cloud also has a diameter of only about 14,000 light-years, which is small compared to our Milky Way, whose diameter is a full 100,000 light-years. A particularly beautiful feature of the Large Magellanic Cloud is the Tarantula Nebula. This star-forming region is one of the most active in the local group of galaxies. The Tarantula Nebula is so huge that it's visible to the naked eye as a bright patch. It contains young star clusters like R136, which is home to some of the most massive stars known, contains R136A1, a blue hypergiant and the most massive star known in the universe. With an estimated mass of about 200 solar masses and a luminosity about 8 million times brighter than the Sun, it is a true behemoth. However, R136A1 is at the beginning of its life, whereas WOH G64 will explode in the not-too-distant future. When this star does explode, it will hurl its mass out into the universe, and from the dust of its explosion, new stars will be formed in star-forming regions such as the Tarantula Nebula. Of course, it would be a real treat for science to be able to watch this explosion live. The Large Magellanic Cloud has already offered the opportunity to observe such a rare spectacle. In 1987, the supernova SN 1987A was observed there. This was the first supernova in centuries that was visible to the naked eye. For modern scientists, it was the first opportunity to study the explosion of a dying star in detail. Betelgeuse, will we see the Betelgeuse supernova soon? When we're talking about supernovae and red giants, one must not forget Betelgeuse. It is the most prominent star in the constellation Orion, and it will also explode soon. However, Betelgeuse has not yet begun to shed its outer layers, so its final explosion is probably even further in the future than that of WOH G64. In 2019, Betelgeuse experienced a significant dimming for several months, sparking widespread speculation. Some scientists believe this could signal the star's imminent end, as it lies approximately 550 light-years away. However, the excitement eventually subsided. As a red supergiant, Betelgeuse has already burned through much of its nuclear fuel and will one day completely exhaust its hydrogen, leading to a final explosion. Predicting exactly when this will happen remains challenging, as our understanding of a star's final stages is still limited. For this reason, much like WOH G64, researchers continue to monitor even the slightest changes on Betelgeuse's surface. The sudden drop in brightness in 2019 is likely attributed to a massive ejection of material. After shedding this mass, Betelgeuse stabilized once again, leaving scientists uncertain about when its explosive fate will arrive. Red supergiants like Betelgeuse contain vast amounts of swirling material, creating powerful convection currents in their outer layers. Occasionally, large portions of this material are expelled, temporarily dimming the star. It is believed that after this ejection, Betelgeuse became enshrouded in a dense dust cloud, causing the observed drop in brightness. Scientists reassured the public by comparing the event to an aging giant, coughing, rather than nearing its final moments.